The first step to our Rube Goldberg machine began by a ping pong ball being pushed off this chair down a ramp. This was all powered by our Arduino motor. It was all kicked off by the push of a button. The ball went down the ramp through some paper tubing and down a V-shaped cardboard ramp, which then knocked over the domino chain, knocking over the last ping pong ball, knocking over the cup of water. Here's another view of the ping pong ball traveling down the first ramp. As you can see, the ramp was very narrow in order to be able to pass through the tube. Additionally, added some paper padding at the bottom of the last ramp to block the ping pong ball from ever falling out. That way it would just trickle down through the small hole. And here's another shot of the last step, which was the cup of water being knocked over by the last ping pong ball.
The first step of my Rube Goldberg machine steps is triggered by the last step of Dylan's Rube Goldberg machine steps. His last step ends with a cup of water spilling over onto the floor after being knocked over. Therefore, my steps begin with me knocking over a cup of water onto the floor. Two jumper wires connected on the solderless breadboard and Arduino, powered by a 9-volt battery, are positioned so that their ends are on the floor, so that when the water spills onto the floor, the wires detect the water. But after a couple of trials, I found that the water was spreading out over the floor to the extent that the tips of the wires were not detecting the present water. To fix this, I cut a paper cup at its base so that it would collect a small amount of water, enough to actually allow the wires to detect the water. The wires are able to detect the water because one is connected through a resistor to ground and the other is connected straight to 5 volts of power. Therefore, having both of the jumper wire ends exposed to water detects the presence of water because the water acts to complete the connection, creating a flowing circuit. That connection is what detects the water, as the input will read a value from 0 to 255. Through testing, it was found that a nice threshold for the input value was 235, so any value read over 235, meaning that there is water present, would therefore result in an output to trigger. That output is a mini servo connected to the Arduino. The servo itself only rotates between 0 degrees and 180 degrees, so when water is detected, the servo is set to 180 degrees from its initial position of 0 degrees. An extender is attached to the top of the servo so that the rotation is more effective. The extension has small holes on the outer part, which is perfect for my next step. What happens is that when the servo spins, scissors connected with thread to the servo closes to cut another piece of thread. This is done by tying one end of the thread to the hole of the servo and the other end being looped around the grips of a pair of scissors. The thread is looped on the scissors in a fashion that tightening the loop would cause the scissors to close, and this is exactly what happens. The servo spins, moving the thread away from the scissors, causing the looped thread to tighten, causing the scissors to close. The servo and scissors have to be duct taped to the table so that they remain stationary while the thread pulls the scissors shut. Otherwise, the servo and scissors would move and result in the thread not being cut. In between the blades of the scissors is another piece of thread that has a ping pong ball taped to its end. When the scissors close, they cut the thread, releasing the ball, therefore allowing it to go through the ramp system I built. The ramp system was built using cardboard and duct tape. Two larger pieces of cardboard were duct taped together to create one big board for the ramp system to be built on. Cardboard strips were cut lengthwise and secured to the larger board by duct tape also. The strips were placed at an angle so that the ping pong ball would travel downward. This was an effective method to building a ramp system, but the duct tape posed as a problem at some points, as the ping pong ball would get stuck on parts where the duct tape would protrude out even the slightest bit. So, trial and error was utilized to figure out where the fixes were needed so that the ping pong ball would travel smoothly through the ramp system without coming to a stop. There were also points on the ramp system where the ball would fly outward, so smaller pieces of cardboard were cut and duct taped to the sides to prevent that from happening. At the end of the ramp system, the ping pong ball shoots out at the end to initiate the next step in the Rube Goldberg machine, which is done by Krish. So, as an overview, the water spills, causing the Arduino to detect the water, outputting the servo to spin 180 degrees, which in turn closes a pair of scissors that cuts a thread attached to a ping pong ball, which goes down a series of ramps to, in the end, shoot out and provide as the input to the next step.
The first step in my machine is the last step in Gavin's, a ball rolling down a ramp. Once the ball rolls down a ramp, is then pushed by fans through a course, and which has barriers. We have to use a ping pong ball because otherwise another ball would have been too heavy for the fans to push. We set these barriers so the ball follows intended course. The next step is the ball knocking over a tile, which knocks over dominoes. There's a barrier between the ball and the dominoes because if there was no barrier, the fan pushed over the dominoes. The dominoes then fall onto a water bottle cap, pressing the Arduino wires into the water that is in the water bottle cap. The Arduino wires then sense the water and turn on a red LED light. Although I ended up making it work, in many cases I had to revise the obstacle course because the ball just would not go in the intended area, and I had to precisely fix the obstacle course.
The final sequence of my group's Rube Goldberg machine, which has an overall theme of providing clean water worldwide, begins with a photoresistor sensing light emitted by a LED, and then this initiates a motor, which then knocks over a ball, rolling it down the ramp, and then hitting some books. This video displays the overall design of my team's final sequence in our Rube Goldberg machine. As you can see, there was a multitude of iterations that were made in the final design from the preliminary one. This allowed the design to be a lot more successful and efficient and accurate. Here you can see the overall completion of our Rube Goldberg machine. The final goal was to raise a 500-gram object 60 centimeters. Our group chose to raise a water bottle to demonstrate providing clean access to water. Just to recap the final sequence, here you can see I'm plugging in a 9-volt battery into the Arduino. This turns on the LED, as you can see, and the photoresistor will sense this at approximately a light value of 63. This initiates the motor, knocking the ball down the ramp, and the books will knock the basketball off the deck, and the basketball will then hit the seesaw, which will launch the 500-gram water bottle into the air.